So, never, I never really like doing this, but I really got to get project contribution out there because it's about today's lecture. So I am releasing some documents and some content that aren't fully complete. So I'll be adding details to this. I just added this requirements paragraph, for example. I'll be finishing up this document and finishing up both of these projects. But I really want to talk about it today. I want everybody to be able to get started on this as soon as possible. So we're going to talk about it right now, and then I'll finish up the documents and finish up the project docs as well. Once we get in there, I clicked go ahead. So today is going to be the Git lecture. I mentioned this a few times of where it's going to go in the course website. Oh, I should add some references here too. This is where it's going to go, and then we'll pick up a lot of other topics after this lecture. And if we need more time for Git, we might need more time for this. We'll borrow from the other ones. I won't ever be asking you to write a GUI, at least not for course credit. So I can downplay the GUI lectures, but it's something I really do want to still cover. But Git, I am asking you to go through this procedure. So if we need more time for Git, that's fine. So the project contribution link is live. Open-ended objective, I'll also finish up this. I have the TAs reviewing the open-ended objective proposals. So some of you may have gotten an email from them already. I don't know. I'm not exactly sure where they are with the process. I know they reviewed everything. I'm not sure if they reached out to all the students yet. But if you submitted, that form is should no longer be available. Let me make sure that's the case. Okay. Oh, cool. The TA took care of it anyway. So they'll be contacting you if they haven't already, if you submitted a proposal. So we are getting the feedback on that. Some of you will have some extra work to do depending on that communication with the TAs. Some of you have to revise a little bit of your proposal, but we'll work with you on that. The TAs will work with you on those. And if you have not submitted an open-ended objective proposal, that deadline is passed. That will be a hard deadline. There's no reason to have that as a rolling basis. That doesn't make sense to approve open-ended objectives later where you're not giving yourself time to even work on it. We're not going to go through that. If you haven't submitted an open-ended objective proposal, you can't do an open-ended objective anymore. You can still get credit for that application objective, but you have to do a second homework expansion instead of designing something of your own creation. So if you wanted something of your own creation, unfortunately the deadline's passed. You missed that opportunity. Some of the projects that were submitted, I'm really excited about some of these. Some of y'all pitched some really great stuff. Some of it's really ambitious. Your feedback from the TAs for a lot of you is going to be, hey, this is really great, but we can scale it back a bit. If you complete just this part of what you're proposing, then we'll give you credit for the course. And then if you complete more than that, that's fine. A lot of you have really ambitious ideas. I'm really excited to see what comes out of that. So we'll have this link up. This link, the open-ended objective submission, it's going to be through an interview with a TA during finals week or earlier if you have it done earlier. And also a submission of your code, which will either be through Autolab or sharing a GitHub repo. I don't know the logistics yet, but your code submission and an interview, it'll be similar to a homework submission. With that, let's talk about project contribution because that's what we're talking about most of the day today. So project contribution, that's we've been waiting a while to see. The two projects are a to-do scheduler, so having tasks that need to get done, keeping track of the tasks that need to get done, and marking those tasks as complete. These documents actually won't grow very much. The one thing I have to do is get the base code up and running for this one and then getting it deployed. But this won't change very much. So the apps for this, the app, once it's up and running, is going to have the functionality to add tasks and mark tasks as complete. And that's it. So that's the base project that has the core structure that you're going to work with. And then for your open-ended contribution, you'll take that code and add something to it. So add some feature to this code. So I have a bunch of suggestions here. Feel free to make your own, but just some ideas to get you started. I put together a list of suggestions for you to make. So tasks can have this could have multiple users if you want to use this for teams and assign tasks to different team members. Having deadlines to tasks and have them sorted by some sort of priority based on their deadline and some specific priority that you give it. The estimated hours for the tasks, so you can figure out how much work is on your to-do list. Filtering based on labels, being able to label tasks. This is for this class, this is for this class, this is for home. All kinds of features that could be added to this to make it a more useful app. The office hours scheduler, or the office hours system. This is, most of you are familiar with at least some version of this idea. Is you go to office hours, you check in to enter a queue, and then the TAs see students off of that queue based on how long they've been waiting. Right now, this one I'm a little bit further on, has some functionality here. Let me pull this out, pull this over. And I'll do the same thing with the, I'll do the same thing with the other app. I just ran out of time. Ran out of time over the weekend. I missed. There we go. So if I'm a student, I want to enter this queue. Oh, work for me. Oh boy. Well, there's your first contribution. Fix the bug. Do I even dare try this during lecture? Oops. No, there's... Yeah. You know what? I'm going to try one thing. Because I want to show the demo to show the functionality. Yeah, first contribution, fix the bug. I mean, that is the point of this. The whole point is that I'm not contributing so much. So for each homework, I'm structuring things. Me and the TAs were working together to get this prepackaged assignment out to you with all these specs and everything. The whole idea of this is I'm providing the absolute minimal amount of contribution, and then you as a class are working together to get the functionality. So here I entered the queue. For some reason I had to restart the app, so apparently there is a bug y'all can fix. I'm entering the queue, and then if this is a TA using the same system, they can say, okay, I'm ready to see another student. The student gets a TA is ready to help you, and you get the name of the TA gets the name of the student who they're trying to help, and they can student 2 because I'm really creative, and multiple students can be in that queue. And then the TA is always going to see. It's going to get a little messed up because I'm simulating multiple users in a single browser. But when the TA is ready to see you, it's going to take whoever's been waiting the longest right now. So that's the office hour system. Very, very bare bones. Of course, that's the same way the To-Do app is going to be delivered to you. And again, a bunch of suggestions. This one, I don't know if I even have to provide suggestions here, because this affects any of you who have been to office hours. You can probably think of 20 different features that you would want on this thing. I would assume, at least. But I gave some suggestions anyway, just to give you some ideas if you don't have any. One big one that you would probably notice that you probably wouldn't like about what I just demoed is when a student is in the queue, only display their number in the queue and don't display the whole list of every student who's been waiting, who's waiting in the queue. You don't want to leak all that information and have that public on the internet of everyone who's waiting for office hours. So if you had some authentication system that has TA accounts and student accounts, and then the TAs could see the full queue, but the students can only see their position in the queue, that would be one of the features. Granted, that's very ambitious, but that would be a feature that I'm sure you would want as a student on the student side. So those are the two systems. So your task is to make some sort of contribution to one of these two projects, going to one of those GitHub repos. I didn't show the repo, but it's a big part of lecture today. Go into one of these repos, hosted at the UB CSE organization, which I created this a long time ago and never really used it too much. But I'm blowing the dust off of this thing and using this just to make sure that you don't think this code is going under my name at all. That you're going to make a contribution to that repo that's hosted as an open source project that the world can use. The world can use these apps. Is the idea here, and this is a common thing out there, is to contribute to a repo like this and get your code out there in the open source project. Since there are 200 people in the class, more than one person could do. Yeah. So, in Spaz Godzilla, good username by the way. This is one of the big logistical things that I had to think about for quite a while. Is how do we do this with 200 students? We started with 380 students. Not everybody's doing the project contribution, I would assume anyway. Maybe they will. I don't know. But we've lost due to resign. It doesn't matter. I'm getting sidetracked there. But if we get like 200 contributions to this, I expect some duplicate ideas. I don't expect duplicate code, mind you. So I'll still be watching just like a homework submission where you're all submitting the same thing. I don't expect duplicate code, but I do expect duplicate ideas, especially if you're pulling an idea off of one of my lists. If you're the type of student who just takes the top thing and says, I'm just going to do that. Well, there's probably at least 5 other students doing that same thing. Just there are a lot of students who just do the first idea because that's the you don't have to think too much. Or if you look through this list and do the easiest idea, a bunch of students are going to do that same thing. So I'm not looking so much at your code that you're contributing, so much as the procedure of how you're contributing that code. If you're following this procedure, which is what today's lecture is all about, is what this procedure means, of contributing code to a repository that you don't have push access to. That's what we're really talking about, and that's what's the focus of this contribution. The actual code you contribute, in terms of assessing your application objective, I'm not going to be too concerned. As long as it does add functionality to the project, I'm not too concerned with the scope of it. I'm not too concerned if it's unique, if it's something that was submitted 100 times, or you're the only one who submitted that. I'm just not as concerned. Mostly for the issue that you bring up, Spaz Godzilla, is that how would I even do that? I would have to do it like the open-ended objective with a proposal, but like 80% of the proposals, I would just be responding with, sorry, that's already taken. The logistics of that would just be a nightmare. So I'm not going to have some requirement like that. Not in a class where I expect 200 students to be submitting this and doing this. So no, you don't have to claim anything. You don't have to sign anything up. The logistics are just almost impossible with that. But I'm still going to look for similarities in all the submissions. If you're just stealing your friend's code and submitting that, there's obviously the AI concerns. But if you're doing the same idea and implementing them separate, that's fine. Make people's names different colors. No, seriously though, Nicholas, if that's what you want to do, the amount of code, and I want to make sure this is stressed enough, the amount of code I'm not going to scrutinize too much. If you're going to this system, well, I don't have anyone in the queue. None of you played with this? None of you added yourselves to the queue? I hope it's not all broken. If all you want to do is make this name a different color, and especially if you let people choose their color, but even if hey, there we go. Hello. If that's what you want to do, even if it is a random color, like, that's perfectly fine. That's a great example, actually, of something that's not a ton of code, but it's something that I would accept as okay, because it does affect the functionality. It does actually affect the project. So, for example, if you're just adding some print statements, if you just open the repo and just mash your keyboard, and I shouldn't have actually mashed. Just mash your keyboard just to say that you have some change made and you completely broke the project or something. That's not cool. But as long as it's something that is adding to the project, you're changing the project in some actual meaningful way, enough to show me that you cloned the repo, you made your change, you tested it, made sure it doesn't break everything, and then contribute it back to the project. That's all perfectly okay. And that's the one of the big points that I want to make with this is less of a final project, a final huge capstone project to 116, and more of a victory lap of, we've gotten through all those assignments, we've done all those lecture questions. Now let's kind of see how contributing code kind of fits into a bigger picture. How do teams of 30 people work together to build one project? How are 200 of us all going to contribute to a single project? And with 200 of us, it's going to be a bit of a mess. But you're still going to see that procedure of how that works, and how when you get out there in the industry, that you're going to contribute to software as a team. Yeah, so it's more of showing that you can work with the GitHub repo and getting that practice, more importantly. Getting that practice of working with the GitHub repo and just going through the procedures, using Git and all that stuff. There's more than 200 students. Please comment your work, everyone. Yeah, I mean, I feel personally attacked, but but anyway, let's get into some juicy content. And I have the slides for the next two lectures, if anybody likes to look ahead. I haven't been ahead on slides as much as I'd like to have been in this class, mostly because I'm tweaking the lecture questions at the last minute. But we're done with lecture questions, so I can get ahead on slides a bit more than I have been. This and this. Oh my goodness, why can't I click the right thing? There we go. Okay, so let's get through some slides. This is worth mentioning too, is given the number of Mr. Muffin, there's more than 200 students still in the class, but I'd say about 200, maybe a little more than 200, are actively completing application objectives. And then I assume a good number of students are focusing on those learning objectives and just trying to pass and get through the course. But at least a little over 200 students who are actively trying to improve their grades beyond the learning objectives. So I would expect about 200 to participate in this. Since it's not too hard, it's, I would say, the easiest application objective, if I'm being honest. Maybe we'll see quite a bit more than 200, but we'll see. And on the please comment your work, everyone, comment, the project contribution is to create the pull request. So none of you actually have to deal with merging with other students' code and working on that end of things. So you won't have to read another student's code and integrate your code with theirs. Now, if you do want to work with other students and really contribute meaningfully to this project, beyond just getting your check mark for the application objective, then absolutely comment your work with people, do all the good stuff that we should all be doing as developers. And for each of those, I didn't point out there, but each of these projects, I made a Piazza post to centralize the discussion around these projects. And feel free to branch off into Discord and other places as well. But preferably post on that Piazza post where the other discussions are happening. So we have one central place that's more official. That Piazza post is the central place for that discussion. So it's not just my doc and a one-way thing. I want y'all to discuss if you want. Yeah, there's more than 150. There's more than 200. And with the wave of AI wasn't too big. We won't see too much of it then. But they weren't participating anyway. I mean, they were, but they weren't. Anyway, so let's talk about how we're going to do this and kind of the procedure. And there's a lot of background that's going to go into this. We're going to talk about Git a bit here, which we've kind of used Git this semester. You've kind of used it a little bit, but we want to talk about how to use it on the other side. So far, you've only pulled my code. We want to see how to push code and contribute code. If I created a table and run one row, it would have the name of the student, and the other row would have the time they're waiting for. Is that going to count? Yeah, I would count that. That's a good example of something where it's not huge. That's a very straightforward task, but it's still something that I would accept code-wise. As long as you're going through the whole procedure, the procedure of cloning the repo, forking the repo, cloning that repo, editing your code, pushing the change, making the commit, making the push, and then creating the pull request into develop. That's the procedure that I'm looking for. And that would be a perfect minimum. Anything less than that, changing that display to a table, anything less than that wouldn't be very cool. I would probably deny, but that's a good minimum amount of code that I would accept. So the bar is pretty low. I'm advertising that. The reason I'm advertising that is because if I don't, a lot of really good students are going to make huge contributions and build all of auth, thinking that that's what they need to do. And then they get upset later when they talk to their friends and they figure out the kind of crap they submitted that I still accepted. So I just want to be open about that my bar is going to be pretty low on the code itself, as long as you're editing the app. And one idea that I forgot to add to those lists is that changing the front end. The front end is very bare bones. There's nothing there. Making the front end more appealing, building a better user experience, those are great tasks as well. Since we don't have to worry about the other students' code, is it possible to do this project without participating in discussion? Oh, yeah. Yeah, you don't have to participate in discussion. I just want, for those of you who want to discuss with each other, I just want that option to be there. I don't want anybody wondering, hey, I'm interested in really working on this project, but I don't know where to go. I just gave that as an outlet for those questions. And questions like this, if it's not during Q&A in lecture, and you want to ask me something, hey, is this going to be acceptable? That's the place you can ask that question. Front end's pretty easy, yeah. For those of you, and I'll know that if you do front end contributions, I kind of know that you're just cheesing it, but at the same time, get your point, do what you got to do. All right, so we have an open source project hosted in a repository on GitHub, and you don't have control over that repo. How do you contribute your code to those projects? This is the big question that we want to answer, so you can get underway with the project contribution. I'm convinced literally TA hates front end. I hate front end. I'll be honest. Front ends, I don't know, I just find it boring. Easy usually translates into boring. So we have this task where the entire class is effectively one large team, and we need to share a lot of code with each other. Of course, you know what these slides are leading up to, but I want to do the motivational slides anyway. And we have to share code with each other. So how do we do this? There are a few choices. We could email each other code. We could use good old-fashioned SneakerNet, where you save your code onto a flash drive, you walk over to the other person, and you hand them that flash drive. But what if two of us want to edit the same file at the same time? There are a few options. We could pull up Google Docs and edit simultaneously. We could try Dropbox, but Dropbox doesn't merge changes. We can't really edit at the same time. And Google Docs just isn't meant for code. Like, that's not what we should be doing. So of course the answer is Git. I won't spend too much time on the motivation here. And there are other solutions. I mean, there are other things. There are ways online where you can do this online. But we're going to talk about Git, Autolab. And some students do actually do that. They'll give another student their UBIT and password and log on to Autolab for them. It's crazy what some students will do. Or UBbox. For professors, like if your professor's just sharing the handout code, that's UBbox is fine for that. But when we have to, when multiple people have to be pushing changes to the same thing, when it's not just a direct download this code, that's what we're talking about here, and that's why we would need Git. And Git is completely designed from the ground up to solve this problem. It's designed for code. It's designed for people to make simultaneous changes to a code base. So we've been using Git already, of course. The examples repo and every single homework handout, it's hosted in a Git repository. And you clone that repository, you get all the starter code, and then you can start working on the assignment, or you can check out all my examples. So you've, at the very least, cloned a repo. Even that, I know some students go to GitHub and either cut and paste the files or download the zip file, which, I mean, there's only so much I can do to get you practice. But in a perfect world, you all have practice with Git, at least on that aspect, cloning a repo and pulling changes. As I make updates to the example repo, you click that pull button and you get the latest changes. That's how the course is set up, to get you some practice, some exposure to Git before we dive into it today. So hopefully y'all have been doing that, but I know that's a little too optimistic. So what Git does for us is two big things: version control and source control. Version control is when we have releases. We want to release code to the public, and you see this in all kinds of software. You see it in the Scala versions, the Java versions. We have that discussion in this class every semester. Is when you want to release a new version of your software, you can do that. You can mark that code at this very moment in time. This is version 2.1.19, and that code base is saved in that entire snapshot of the code is saved, labeled as that version. And then as you continue to work on the project, you can always go back to a previous version of the code, a previous release version. Also, source control. So in between releases, it's going to track every single change that's made to that code base. For those of you who look through my examples repo, you can see all my commits, all my changes that I make to the repo. You can go back in history and see everything that I did to that repo since the time I created it. Every single time I pushed new code to that repo, you can see all of that evolution of that repo over time. Or any repo. The homework repos are mostly just one commit. So there's not much history there, but the examples repo, you can get an example of going back in time and watching all those changes. We can also create working branches, so we're not affecting any stable code as we're developing new features. And this is something we'll talk about in these slides quite a bit. And then as we work on our separate code, we can merge that so two people can work on their own branches, merge that code back into the main project. So Git is a distributed version control system. There's one central repository running on a server, and then anyone who wants to work with that repository can clone that repo, which creates an entire local copy of that repository on their hard drive. This repository, when you clone a repo, when you get the examples repo, that code or a homework repo, you are making an entire copy of that entire repository. Every branch, every commit, all the history of that repository, absolutely everything is copied. What you have on your hard drive is everything that GitHub has on their server. GitHub, for our purposes at least. You have a copy of that entire repository. So this is distributed if this in the sense that if this server goes down, you still have the entire repository. You could effectively act as the new server. There's nothing special about the server itself. So it's a very distributed system. Everybody has all of the information. It's not a server that you're interacting with and the server's locking down a lot of features. You get the entire repository. And then you work on your local copy of the repository and push your changes to the repo. We'll talk about these steps throughout this lecture. We can talk about these things in the Q&A, but about what counts and what doesn't. But I mean, you're already confirming some suspicions of some, I don't know, stereotypes. What is it? You're all just fishing for the smallest thing that you can do. Like, why don't you care about learning this stuff and making meaningful contributions? It's always upsetting to me. I expect it, but come on, man. You're just looking for the easiest way out. Try to learn. Try to learn without being forced to, is my advice to you. So let's take a look at some Git commands. We're going to look at how to make a repo, update a repo, connect to a remote repo, and also pull changes that have been made to a repo. So creating a new repository, init is the official command, the Git command if you're using command line, to create a repo. Yeah, I know you spent tons of hours already, but it is, for every assignment I have, maybe it's not the same students, but every assignment from the very first one, there's students that do this stuff. It's just a constant in my life of having students try to find the easiest way out. I get it if the semester just wore you down at this point, but if you can handle any of the assignments that have been out there, you can do more than changing style on an HTML element with ease without even breaking a sweat. So init is the Git command to create a brand new repository. You really won't have to use this one if you are creating a new repository. You'll do it through GitHub or IntelliJ. And for the project contribution itself, you won't have to create your own repository. The repositories are already there for you created. But GitHub and IntelliJ will call init for you under the hood. If you click their buttons on their interfaces, they'll create this. Repository. For our purposes, we'll use clone. This is going to download an existing repository. So that image that we saw on the other slide, where you have a server hosting a repository and you want a local copy of it, clone is what you want to call for that. Clone a repo, or in IntelliJ, check out a repo from GitHub and get a complete copy of that repository locally. To update a repo, there are 3 steps involved with this. This is one thing, especially if you're new to Git, you think, why isn't this just one command? Just say, update my code with the server. It's actually 3 separate commands, so let's break this apart and talk about the 3. If you're working through IntelliJ, which I recommend, these 3 will kind of blend together into pretty much one button click. But let's talk about what each of these 3 are doing. Add is telling Git that, hey, this is a file that I want you to track. Commit is taking any local changes made in your editor and adding them to your local copy of the repository. And this is where you're going to add commit messages and give some meaningful description of the code that you just committed to the repository. And then finally push, which takes your local commits that you've made to your local version of your repo and updates the remote server, pushes those changes to the server. GitHub in our case. So these 3 steps all have to happen. Hey Git, this is a file I want to track. Commit it to your local repo. Push it to the remote repo. Common mistake, you commit changes but never push them, and nobody can see those changes. If they're not pushed to the remote server, nobody else on your team can see those changes, only you, because you only committed them to your local repository. Please make your Git commit messages meaningful. We all have a tendency to do this. XKCD, they really nail it with this one. Over time, commit messages become less and less meaningful, but try to keep these for your project contribution. You're only making a handful of commits. Keep those commitment messages meaningful, so when you're looking back through the history, you can see where something came from. And especially when you get out there in the world, you're going to thank yourself. Your future self is going to thank yourself if you have meaningful commit messages. When you have a feature that breaks sometime in the future, and you're trying to look through the history of how this feature was created, like why were these design decisions made, those commit messages can help at least a little bit in doing that detective work later on. Especially if you have a very large project, these commit messages are very important. When somebody else makes a change to the repo, to the remote repo, pull is going to take all the commits that are made to that remote repository on the server and copy those down to your local copy of the server. And a mantra you'll hear often related to Git repositories, pull often. You're working on a team, a lot of people are making changes. Pull often. Always be pulling that new code, get that fresh code on in your local copy. So then you know if the changes that you're working on are going to conflict with the changes that your colleagues are working on. You want to be able to tell if there's a conflict early on in the process, so you don't have 2 features that are incompatible with each other. For project contribution in this class, I mean, we're just going to have lots and lots of features that are incompatible with each other. If 2 of you change the database, change the SQL table, it's almost certainly going to be a conflict that those 2 features will be incompatible. So that's just something we'll live with this semester for the project contribution. But out there in the world, you would pull often, make sure your changes are going to be compatible with what everybody else is working on. With 200 students all contributing, it's just infeasible. That's why the requirements stop at the pull request, and we don't have to have it merged in and do a review process and everything, which would be cool to add, but just infeasible. Maybe someday. So the overall structure is you have this remote repository on GitHub. For our purposes, it doesn't have to be GitHub. You clone that to get a local copy of the repository. You have your index, which is all the files that have been added to Git, all the files that you told Git to track. And then finally, your workspace, your actual text editor or IDE, whatever you're working with to physically edit the code. When you edit the code, you're going to tell Git to track any files that you've edited, which in IntelliJ mostly happens automatically. Sometimes you have to do it manually. Then you're going to commit all those changes to the local repo, push them to the remote repo, and then that change is there on GitHub for everybody else to see. You're going to pull to get all the remote changes updated through all your local copy of everything. And that's really our process. This process up here is how we're adding code. And then pulling, checkout, you probably won't have to deal with this, but if you want to check out a different branch or a different commit, different piece of history, you can check out specific versions instead of always having the latest version of the code. Pull, add, commit, push. Well said. Well summarized. So GitHub is what we'll use in this class, and it's pretty much dominated this part of the field. Is GitHub will provide hosting services for Git repositories, and also nice web interfaces, being able to interact with our Git repositories. So Git is the version control software. It works with command line arguments. There's no bells, no whistles, no thrills, just raw features to be able to work with code. GitHub is hosting that online on their servers, and also giving us that web interface to be able to interact with our repositories in a more more user-friendly way. GitHub is not Git. These are two completely different things. GitHub is a server to host Git repositories, and Git is the software that's actually doing the version control. It's actually doing the merging, the pushing, the pulling, the committing. That's all Git. What is forking repo? We'll get to that. I'm trying to get to that part, and then we can digest this over. Actually, I just looked at the slide number. We're never gonna get there today. But let me get as far as I can, and then I can talk about forking if we don't get to it. I'll at least talk about it during the Q&A. So branching is the next level of this. So all of this assume that everybody's working on the same. Oh, I have it on the next slide. Assumes everybody's working with the same exact code base and pushing and pulling to the exact same code base, which isn't usually the use case that we have. So this is how we can share all this code. But instead of always all working on the same code base, we'll use what's called branching to effectively make a copy of the repository, or at least a copy of the code base in the repository, and work on that code without affecting the rest of the team. So a branch, you'll work on your own branch, which is a copy of the code. Any changes you make there, any commits, any pushes you make to your branch only affect your branch, only affect that branch. So if two people are working on separate branches within the same repository, they can both push code to the repo without affecting each other at all. And once you have a branch and you're happy with the changes you've made on that branch, you can merge that back into the main repository, the main branch of the repository. So a repository can have many, many branches, which are all different copies of the code at different states of development. And there will always be a branch or two for the main branches of the project themselves. I got a little ahead of that. When you're done with a branch and you want to merge it back into the project, you'll do that via a pull request. So you'll say, this feature is ready. I'm ready to merge this into the main project. You create a pull request. Other developers on your team will typically do a code review here. This is where, if you've ever heard of code reviews, this is where that happens, on the pull request. They'll review your code. If they approve it, they're going to accept that and merge it back into the main branch of the project. In these code reviews, these can usually be lengthy conversations. There can be a lot of back and forth here typically, but this is where you're going to say, this feature's ready. Let's talk about it and get this added to the project so our users can use this feature on the next release. So let's look at an example branching model, and this is the one I'll use in the repositories. Is fundamentally based on these two main branches, master and develop. So these are the two main branches that are used in a repository, and this is a very common setup out there. Most repos will have master and develop branch and feature branches that we'll see. So the master branch, this is the default branch. When you create a repository, you get a master branch, name master. That's going to be the primary branch for the repository. For this branching model, we'll only use this for stable releases, and this should always reflect the state of the code that the users are able to see. So this is the latest release, the latest numbered release of the software. That's what always lives on the master branch, and master is only updated when you're ready to release new software to the user. The develop branch is going to be the current state of the project with all of the latest features that are complete. And this includes all unreleased features. You might have a lot of features in develop that are not yet released to the public, to your user base yet. And visually, if you want to check out where a really good write-up of this branching model, I like this post. Go to that link and check out a good overview of this branching model. So you have master, you initially create your repository, create a branch off of that, name it develop, work on your features here, and whenever you're ready to release to the public, you update your master branch with those latest features and update that code, merge develop into master, and have that next release. and you're always working on new features in develop. A feature branch is where all the action happens. These are temporary branches off of develop, and this is where you're going to work on new features. If there's a new feature idea, you have an idea for a new feature, or you're tasked with building a new feature, you branch off of develop, create a complete copy of the develop branch with all the latest features that have been finished, work on your new feature on that feature branch. That's where you're doing your commits and your pushes. And then once your feature is complete, you'll merge it back into develop, usually with a pull request. And you hope it doesn't break things. It might. It certainly might. You merge it into develop, and then do all your integration testing. Test the new develop with that feature, and just make sure nothing broke. It might break. If there's no chance of this breaking anything, even though your feature works great independently, it might conflict with another feature that was added in develop. So if it never had a chance of breaking, we would just merge this right into master and release it to our users right away. But there's possible integration bugs here. So we want to test that before we release this to our users by merging into develop and having that feature there. So if multiple people on your team want to work on new features at the same time, you each create your own feature branch, work on your features. Each of you, when you're done, you merge back into develop. Once you merge into develop, you usually delete that branch. You're done with it. These are temporary branches. And that looks like this. You merge off of develop, work on your feature. Other people might have merged features into develop in the meantime, and then you merge your new feature back into develop, staging it for that next release, that next public release. Every time you release to the public, you'll merge into master, give it a new version number, and then release that code to the public, or that compiled code, usually release that to the public. And there's a few types of branches that we really don't need to talk about here, but here's the overall picture of the whole thing. You have your initial code, you branch into develop, you work on new features, you get new features. As you have features ready to be released, you release them, tag them with version numbers, and then release those to the public. So this project would have 4 public releases and a lot of action going on behind the scenes. A fork, we did get here. We'll at least get through these slides. We can go back through them during Q&A. I might take some lecture time out of some other lectures. Maybe I'll push everything back by a day and take a day away from the MMO stuff next week. Or actually, we have the whole last week of review. I can take a day out of there and just push content to the last week. So forking a repository, but since you have to do this stuff, I want to give it more time. Forking a repository is different from branching, but very similar. You're going to make a complete copy of the repository that's going to be your copy of the repository. So on GitHub, there's a button to fork a repo. So this is the first step of your procedure in editing code. You'll go to my repository. You'll go to the CSE repository for the project. You'll clone that repo, and that's going to make a complete copy of that repo on your GitHub account. So you'll have a complete copy of all of this code on your GitHub account. That's your repository that you control. You have full access. Nobody else can access that unless you give them access. That's your repository, but it is a complete copy of that presumably public code, because you can fork any public repo. You can go out and fork. You can go to any of the libraries we've been using in this class. You can go to those repos on GitHub, fork them, make changes if you want. That's your copy of the repo. You fork a repo, that's yours. But you can't go to CSE and go to one of those repos and just start making changes because you don't have permissions. Forking is a way to make changes to a repo that you don't have control over. This is different than branching, because branching is a copy of the code base inside a single repository. Forking is making a complete copy of that repository that nobody with controlling that original repository can even see or control or access. Usually they can see. If you're forking a public repo, you should have your fork public, but that's besides the point. And once you fork a repo, an overview of our procedure combining everything we just talked about, you'll fork a repository on GitHub, clone that repository, your forked repository in IntelliJ, edit your code, make all your changes with your project contribution, commit and push those changes to your forked repository, and then create a pull request from your forked repository into the develop branch of the original repository. So we're using forking as a way to kind of simulate branching, but on a repository you don't control. And this is the typical procedure for contributing to an open source project. If you want to contribute code to an open source project, you don't ask for access to their repository, but instead you can fork their repository, make your change, and then submit it in a pull request. And then if the team likes your change and it doesn't break anything, then they might accept your pull request and merge it into their project. This is the standard procedure for contributing to an open source project. And this is what we want to get practice with through the project contribution.